Hello, everyone, and welcome. I'm just going to give it about a minute as attendees start trickling in, so just bear with us for a little bit here while we wait. Hello, everyone. Thanks for joining us. I'm just going to give it about another 30 seconds to let everyone slowly trickle into this webinar, so just be patient. All right, everyone, I think we'll start now. I hope you all can hear me okay. So good morning and afternoon. We're super excited to have you all participating in Keela's 3-day virtual conference called Plugged In. If you attended our morning sessions so far, welcome back. And if you're just tuning in now, well, welcome and thank you for joining us. But before we begin this session, I just wanted to go over a couple housekeeping details with you all. So first, this session will be about an hour in length, which includes about a 10 to 15 minute Q&A session. We encourage you to ask questions throughout the presentation in the Q&A box, and then we'll try to get to all of them at the end. All the sessions will also be recorded, and you will receive the recording along with a slide deck by the end of this week. All right, and with that, I'd like to introduce and extend a huge warm welcome to a speaker who we are very excited to have join us today. She was supposed to speak at N10's NTC conference that was unfortunately canceled recently, but instead she's generously offered to lead this session online with all of you today. So with that, I'd like to welcome Ria Sankar, who is the Director of Program Management at Microsoft and founding member of AI for Good. The title of her session today is Getting Started with Data Science and Machine Learning. Thank you so much all for being here today. And Ria, I'll pass it off to you now.
Thank you, Mel, and thank you all. Thrilled to be here today. As Mel mentioned, I'm part of Microsoft's AI for Good team. And as we all know, the nonprofit sector has tremendous opportunity to fight inequality, eliminate poverty, and protect human rights. But very often, we fail to leverage data and AI in a compelling way in our programs because we lack the right data or we lack labeled data. I'm here today to share some of what I've learned in building AI and machine learning applications over the past 15 years in products like Oracle, Microsoft News, Azure, and Bing to help you on your AI journey as you can focus on the outcomes that matter most to your organization without getting mired in the details of the data. Once again, thrilled to be here. This is a lot of ground to cover in a short period of time, so keep those questions coming, note them down, and feel free to ping me later on Twitter or LinkedIn. Let's jump right into my presentation. Can you guys see my screen okay?
Sorry, yes, we can absolutely see it. It looks fabulous.
Awesome, thank you. And as I mentioned, there's my Twitter and LinkedIn. If you have any questions that we can't get to by the end of this session, please feel free to reach out to me. Let's rock and roll. Microsoft's AI for Good started out with 3 key pillars. We've since added 2 pillars, AI for cultural heritage and AI for health. But our largest investment to date continues to be our flagship investments in AI for Earth, where we work with environmental organizations across the world to solve key issues like wildfire prediction, animal poaching, and climate change. Within AI for Accessibility, our mission is to unlock opportunities for 1 billion people living across the world with disabilities through solutions like Seeing AI, mental health opportunities, and immersive sign language experiences for people who are deaf. AI for Humanitarian Action, arguably my favorite pillar, is a $40 million 5-year initiative that is focused on 4 key pillars: disaster relief, the needs of children, refugees, and human rights. We like to approach disaster relief with a 3-pronged approach. The first step is to build a deep understanding of the buildings and streets across the globe. We partner with the OpenStreetMap, Bing, and Facebook to launch the first ever comprehensive database that has cataloged remote areas in Africa, which were previously unmapped. The next step is to understand and automate needs analysis so the right responses can be delivered in a timely manner when disaster strikes, and understanding the needs that are specific to specific disasters. Needs during hurricanes may be very different from needs during a health advisory, which may be very different from needs during forest fires. And our goal is to catalog and influence responses in these unique scenarios. The third step is to mobilize in near real time the most qualified personnel during times of disaster. Our role here is to build matching algorithms that can shorten relief time from a matter of weeks to a matter of hours. Every 10 seconds, a child dies of hunger across the world. Within the United States alone, over 4,000 children die annually of sudden infant death syndrome. This is the equivalent of losing 2 school buses full of children every week. And our plan is to build the world's first genomics database to address infant mortality and tackle poverty, not just physical poverty, which is malnutrition, but also address the social and economic needs of children living with poverty. There are 68 million refugees living across the world today, a number that has steadily increased since World War II. In this area, we can help by building automated telephony systems that can improve communication between asylum seekers, refugees, and the legal governments. We can build chatbots, and we can leverage deep learning and AI to run deep conflict analysis so the right humanitarian response can be deployed when it matters most. Last but not least, the protection of human rights. There are 1.2 million children across the world who are trafficked every year, 200,000 in the UK alone. Every 2 minutes, a child is prepared for exploitation. This is why we are proud to partner with the Global Emancipation Network and police chiefs in the UK to address this problem in new ways, starting with the UK and hopefully across the world very soon. These are compelling problems, but despite a proliferation of data tools and technologies that automate various parts of AI and machine learning lifecycle, it's tough to know where to begin. It's easy to get mired in the details of data preparation and lose sight of our true north, our customers. It's important to recognize from the get-go that big data and AI and machine learning may not always be your solution. True AI is about using data to make decisions, to deeply understand biases within your data, knowing what data to collect, and building the right team to understand and interpret the data so the outcomes can positively impact those that need it most, especially in our sector. I wanted to start by sharing 5 lessons that I've learned along the way. The first one has nothing to do with data. It starts with customers. OXO Good Grips is a great example of a company that revolutionized and reimagined an industry that had been unchanged for decades. They chose to run in-depth observation studies. They sat down with customers to understand unspoken needs that then materialized and changed into data from surveys and observation studies. A great example of a company that reimagines customer empathy within the nonprofit sector is Team Rubicon. Team Rubicon prioritizes first and foremost its customers as the veterans that serve them. The rationale being happy employees, happy veterans, by instilling a new sense of purpose, can influence outcomes far greater than themselves. The oldest reference to the law of unintended consequences takes us back to British India. The government tried to tackle the venomous cobra population by offering a bounty for every dead cobra. Very soon, enterprising snake charmers realized that was most cost-effective to raise cobras for a living and deliver them dead versus hunting those in the wild. Before the government became aware of what was happening, the cobra infestation had become much worse. There will always be people who try to game the system. We see this even today in rewards platforms, gamification efforts, engagement initiatives, crowdsourced data labeling efforts. Our best mitigation plan in these scenarios is to instrument for leading indicators of failure, to understand and predict how things can go wrong and build in feedback loops to provide early warning. We can only do this when we have diverse teams. We have a lot to learn from the medical industry that requires new drugs to perform better than placebos for approval. The placebo effect signifies the importance of having a control sample. It's also very useful when you're up against strong beliefs in your organization to have hypotheses that are grounded in customer needs and grounded in data that supports those customer needs. We all know that correlation is not causation, but with proliferation of data visualization tools like Tableau, Google Analytics, Power BI, it's easier than ever to imply causation when not intended. The best remedy is to supplement data with qualitative insights and be aware that proving causality requires a very rigorous approach to experimentation. Always err on the side of correlations rather than implying causation when you present to your organizations and partners. There's a lot of scrutiny in the press today about age and gender-related bias, but the truth is, bias is everywhere. There are over 150 types of bias that are categorized into broad categories in the SEEDS model of behavior and bias. The best example of the self-selection bias is what you see here, how people self-selected themselves into exit polls that had the outcome of the 2016 election wildly incorrect. The best way to avoid bias is to build comprehensive data collection strategies and setting up a diverse team. But this only solves for scenarios where we know bias exists. A more challenging area is to address and solve for unconscious bias. And that's an area that continues to need a lot of research. The best way to solve for unconscious bias is to implement peer review processes and continuously review your outcomes and your insights for age, race, or gender-related bias. Assuming we have the basics covered in data collection and data preparation, there are 5 easy steps to get our organizations started with data. The first step is diverse hiring. I've mentioned a couple of times already that the best way to deal with unintended consequences or the best way to deal with bias is to have a diverse team. But diversity goes beyond age and gender. Diversity, when we talk about data and AI, is about diversity of skills, experience, and education. Within our AI for Good team, we focus on hiring from a range of backgrounds: water resources, genomics, mechanical engineering, to support and avoid a tech bro AI culture. If you're building an organization or a data team, then finding the right mix of professionals within the data profession is important as well. We have PMs, data analysts, data engineers, and data scientists. Find the right mix and optimize for one of 4 things: structure, process, rigor, and speed. Also important are organizational investments in building a trustworthy, ethical, and transparent culture. This is why Microsoft was one of the first companies to come up with the FATE principles that can govern the responsible use of AI. FATE principles can help you think through unintended business consequences and help you determine the cause and effect of the solutions you're building. Once you understand cause and effect, you can better determine the response when you deploy AI algorithms in the broader world and learn to prepare for them early on. We talked about Team Rubicon as a leading organization that puts their veterans and their volunteers first. Team Rubicon believes in instilling veterans a new sense of mission and purpose. Team Rubicon believes in the sum being, the whole being greater than the sum of the parts. When you get started with any AI or machine learning program in your organization, it's important to start with your customers' functional, social, and emotional needs as the true north. We can do this using qualitative and quantitative studies. If you're a mature product, if you have an existing measurement system and data collection strategies, you're in luck. You can get started with behavioral data analyses. But very often in the nonprofit sector, we have to create new data, and we can do that by running various qualitative research studies, observations, focus groups, ethnographies, diary studies, sitting down similar to OXO and understanding really what your customers want and how we can influence outcomes. There's a lot of manual data. Transforming manual data to digital data that can be then transformed and read by an AI application would be key as well. Once you have a great understanding of your customer needs, it's important to then translate them to a learning plan, to define the key hypotheses and beliefs that you believe will influence the best outcomes for your customer. And that looks like this. Take the example of an effective salesperson. A salesperson is considered effective if they're knowledgeable, friendly, and responsive. And there are various ways in which we define what knowledgeable, friendly, and responsive means. These are general descriptors, hard to measure. Translating them into specific scores and numbers makes it easier to measure. And last but not least, it also helps you increase the frequency of measurement so you can build in leading indicators and predict failure before it happens. This is a quick look at how you can transform beliefs into metrics and use the right frequency to influence the results you want rather than unintended consequences. Great insights, great AI lies at the intersection of audience, your customer needs, the business problems and the results that you defined in step 3, and great data. We talked about how easy it is to get mired in the details of data and lose sight of our customers. What I'd like to share is three easy ways in which you can instill a culture of experimentation and AI in your organizations before reaching out to consultants or partners that can create the last mile of AI for you. Perhaps the most important difference between AI-driven organizations, between data-driven organizations, and other organizations is the life cycle of a belief. In a data-driven culture, in an AI-driven culture, beliefs are tested rigorously. With the qualitative and quantitative studies we looked at before, you can create and generate labeled data. Labeled data from surveys and observations can then help you run offline studies and hypothesis tests. Once there is a significant difference, these become your hypotheses for more complex machine learning or online experimentation. The outcomes of machine learning and experimentation when tested can then be ready for deployment. As a company within Microsoft, we believe in never releasing half-baked AI solutions. Releasing an immature AI or machine learning product is probably one of the worst things that one can do with data, because when AI is immature, it results in unintended consequences, very similar to the Cobra effect. Test your beliefs rigorously. Establish quick hypotheses testing within your culture before you progress on towards deeper machine learning. When thinking through how to get started with data and machine learning, we all know that data literacy requires capital investments in the infrastructure, tools, and trainings that perform all the 5 processes shown on this slide. It's very important to make these investments to get to a single source of truth. But more important is the documentation that surrounds those investments. Implementing a data dictionary that clearly documents business rules and transformations is essential. Ensuring that you have your privacy and legal teams understanding the implications of data, understanding the PII, the privacy implications, the security implications, the responsible use of the data is more important, if not equally important, than the capital investments, the infrastructure investments you make in data ingestion, collection, labeling, and access. The second most important skill in terms of data literacy is data visualization. Investing in the basics of graphical understanding can help you determine quickly what are the key outcomes that will make your customers most happy. Graphs and visuals also help you identify data issues that you can fix before starting or embarking on an AI journey. We talked about how hypothesis testing can help you determine quickly, with the right level of rigor, what are the key outcomes that you need to move forward into the AI and machine learning phases. Here is a quick checklist that you can use, a set of tests that you can run directly in a famous software application called Microsoft Excel. You don't need to know Python. You don't need to know R. You don't need to invest in a SaaS license. Within Excel, here are some quick hypotheses you can test and run before embarking on your machine learning journey. Once you have your data in place, once you've generated labeled data, once you've isolated data issues with graphs, and you have your key hypotheses, now we're ready to talk about AI progression within our organizations. And for this, we have a lot to learn from the marine industry. Long before the Titanic crashed gloriously into the ocean, there were sailboats, they were pre-engine. And then we had engine inside ships. And now we have engine-first ships. The journey took years to get right. And this is not so different from how we should think about AI. AI is a complex process. We often think of AI in terms of self-driving cars, but the truth is AI has been around for a long time. And as you think about getting started with data science and machine learning, know that it's important to build building blocks along the way. It's easy to boil the ocean and look towards AI-first solutions, but build those building blocks. Take the time to get your data and your AI right. The best example of pre-AI solutions are Google's auto-suggest and Bing's auto-suggest functionality. It took years to get these applications right. Even recently in the press, there was a lot of scrutiny about the types of bias that exist in autosuggest, even today, 10 years into the search industry, when it comes to polarizing queries like gun control, women's rights. These are learnings that we can take with us into the nonprofit industry. Taking the time can ensure that we protect the vulnerable customers that we serve. AI inside. Google Photos is probably the best example of AI inside applications, and yet it was exposed to problems of bias. Once again, data maturity is important before we build AI inside solutions. And then other vanguards of AI examples, we have Tesla, self-driving cars by Uber and Google. These are the true AI-first solutions built with years of experience, which have various pre-AI and AI inside solutions inside them that build up the bigger picture. Great example of a pre-AI solution that exists in cars today are the rear view monitoring, blind spot detection, and automated braking. The auto industry has for years tried to implement rules and regulations. 20 years ago, there was an effort to build self-driving cars, but we were not ready in terms of the mapping functionality that was needed. We were not ready in terms of blind spot detection. We were not ready in terms of object detection to facilitate automatic braking. It has taken 10 to 20 years to build these components, these pre-AI solutions that will very soon surface in AI-first self-driving cars. The same is true for the nonprofit sector. Let's work together to determine what are the building blocks we can put in place today to build true AI-first solutions for our sector in the future. We often grapple in our industry with lack of labeled data. Here are some examples of crowd AI solutions that you can learn from to implement data gathering and data labeling for your companies. On the left is the Stall Catchers program released by the Human Computation Institute out of the Cornell University to label mouse brains to accelerate Alzheimer's research. On the right is the famous Waze application that uses input from users to isolate traffic, isolate police cars, and other anomalies in traffic conditions. Similar applications can help us gather much needed data within the nonprofit sector. With an understanding of AI progression and the time it takes to build solid AI applications, the time it takes to gather labeled data, Let's take a quick look at the top types of AI models that you may want to use. Before I jump in here, one more caveat. It can take 4 to 8 months to gather labeled data, but it's important to take the time to get it right, and it'll pay dividends down the road. Typical AI models. Perhaps the best resource in learning machine learning is the scikit-learn machine learning library that talks about the 4 broad categories of machine learning: classification, regression, clustering, and dimensionality reduction. Once you have your customer needs and your KPIs and your hypotheses, think about if you have labeled data and if it's sufficient enough for supervised learning. If not, you might need to use unsupervised learning methods like clustering or deep learning. Think about the frequency of outputs. Do you need near real-time AI models, as is often the case for fraud detection, or can you live with batch processing? This has serious implications on your infrastructure investments. Classification versus regression, generalized versus discriminative, instance or model-based. I have a few examples to share with you that can help you determine what is the right type of model to use in a few scenarios. Last but not least, it's good to be aware that there are ensemble methods that combine different types of AI models together to make the outcomes more robust and more responsible. Here's an example of a classification algorithm. If you wanted to classify cheese into 4 to 8 categories, the right method, the right algorithm to use would be classification algorithms like SVMs, support vector machines. If you were analyzing weather patterns to uncover trends, you could use clustering. If you had to predict a value of 43 degrees Fahrenheit or 29 degrees Fahrenheit, you would use regression, which is very robust in predicting values. On the other hand, if you were to analyze weather patterns to forecast and classify the next 10 days into one of 4 categories, cloudy, windy, rainy, or sunny, you would once again use classification algorithms like support vector machines. If you're looking for fraud detection, especially in scenarios where you're receiving donor payments and federating them across various beneficiaries, fraud detection is essential. Very often, it's hard to determine the anomalies and the root causes for fraud, and anomaly detection algorithms are invaluable in finding outliers, spam, and fraud. These are but a few examples. If you have more examples and scenarios, please reach out to me and we can discuss at a high level what is the right model to use. I'm happy to scope and help you define the outcomes that can help move the sector forward. Here are some typical AI for good solutions that we've deployed in the past year or so for the nonprofit sector. From lowest to highest complexity, we have chatbots. Chatbots for refugees, optical character recognition that can review intake forms, that can help parse migrant questionnaire and link different immigrants and reunify families. Matching algorithms that can identify the best veterans that are qualified for a particular type of disaster response, like hurricanes or forest fires. Recommender systems that can match donors with beneficiaries. Direct data analysis to understand the correlations between nutrition and population density and the socioeconomic variables. Image processing to understand and detect weapons of conflict. Acoustic detection, once again, to detect weapons of conflict based on acoustics and sound detection. Deep learning NLP and object detection for conflict analysis. fraud and outlier detection for payments, genomics understanding to build genomics database and address infant mortality. There may be more. If you have any problems that are either similar or if you have new problems, reach out to me and we can figure out a solution that's right for you. The most important takeaway is a data-driven culture is a culture that not just stores data, but acts on data. According to the Cotter model of organizational change, 85% of ideas and outcomes and transformation initiatives fail before they start because they were not supported by a sense of urgency. Storytelling is a huge, crucial step in success in building allies and ensuring broad adoption of your insights and proposals. On August 28, 1963, in New York, during March on Washington, more than 250,000 people gathered to hear Dr. King speak. He sent no invitations or flyers, and yet people flocked to hear him speak because he communicated his beliefs in a compelling way. His gift for storytelling compelled those who shared his beliefs to gather together to advocate for his vision. His vision became theirs. Within the nonprofit sector, we have limited resources. The best tool we have is the power of storytelling. We need to move mountains with close to nothing at our disposal. Storytelling is the #1 feather in your cap, to advocate for your vision, your sense of purpose. I work with leaders across the nonprofit sector, the CEO of the Global Emancipation Network, the CIO of Team Rubicon. These are compelling storytellers who've translated their purpose, their vision, into compelling stories that mobilize teams across the globe. We follow leaders like Dr. King because we share their vision. I hope we can all lead with authenticity and insight, and above all, communicate our sense of purpose in a compelling way. Data is the real currency of your company, but use the power of storytelling to mobilize your partners and drive change with data. Thank you. Look forward to hearing your questions, and please feel free to reach out to me via Twitter or LinkedIn.
Thank you so much, Ria. That was great. Just waiting for all the questions to come in, so just give us a moment here. We've got quite a few people on, so I'm curious to know what everyone's thoughts are on Ria's talk.
Or any topics you'd like covered in a future session, any areas I might have missed. I'm sure there are plenty.
That's a good suggestion too. Samantha says that was so interesting. I agree. Thank you so much. That was great. Anyone else?
Thank you, Laura.
Lots of people are in the chat saying thank you so much. Oh, here's one that comes in. Ria said that data analysis, in brackets, to analyze true correlations between variables is some kind of AI. What does she mean by that? Ultimately, this kind of analysis is done by analysts. Can she elaborate a little bit?
Absolutely. So there are different levels of correlation. What I mentioned was that one of the lessons I've learned along the way is that correlation is often represented as causation. Proving causality requires complex forms of AI. You're absolutely correct that Analyzing correlations between variables can be done by analysts, but analysts are also AI and machine learning professionals. They are just one of the cogs in the wheel of AI. There are four different types of people within the data profession. They are the PMs, the data PMs who work across partners to define outcomes. Then we have the data analysts who analyze data, look for correlation between variables. We have the data engineers, the third discipline. They build the infrastructure and the platforms, they stand up the cloud services, they troubleshoot issues with security, privacy. And lastly, we have data scientists. These are often the glorified people in the organization, the highest paid as well. They can help translate your correlations and look for causation with complex machine learning. That being said, an AI savvy or machine learning savvy data analyst could use regression. Even within simple tools like Sigma Excel and Minitab, they could use simple regression models to identify correlation before causation analysis is performed. I hope that answers your question.
Great. Thank you so much, Ria. We have a lot of questions coming in now, so I hope we can get to all of them. So one is coming from Hira, and they are asking, for a small nonprofit wanting to leverage data and tech to scale its impact, what would be some of the key starting points?
Yes. The first step is to make sure that you have data and that you have enough data and that you have enough labeled data. Estimating the amount of data can be very tricky and varies by scenario. I'll share a couple of examples. If you're looking for deep learning text analysis, you might need a few thousand records of data. If you are needing object detection, it can vary between 5,000 images to 10,000 images. If you have 3 variables that you want to tie to outcomes, if you have 12 variables, then that number increases to 40,000 images. So those are just some examples. The key challenge we've seen in the nonprofit sector is that there's not enough data and there's not enough labeled data. So investing in that is the first step. I would also encourage you to build out a data dictionary that documents the data that you have today and get sign off from your privacy and legal teams, because very often as nonprofits, we deal with very sensitive scenarios like trafficking or even malnutrition. These are sensitive human parameters that it's great to have a legal and privacy person on board from day one to make sure that they're capturing any unintended consequences that you might have with AI.
That's great. So the next question is coming from Ines, and she is asking, can you talk a bit more about the AI for Earth initiative? What kind of projects is Microsoft supporting?
Yes. We work with a lot of the environmental agencies across the world. The top scenarios are wildfire prediction, animal poaching, detecting beluga whales in the wild. We also are working on climate change. Microsoft came up with a very bold initiative to be carbon negative by 2050. That's actually now jumped to the top of our queue. So climate change, animal poaching, forest fire prediction, disaster prediction, socioeconomic metrics, and detecting beluga whales and other such animals, endangered species in the wild.
Wow, that's so amazing. And Laura says, love that initiative. Thank you.
Thank you.
Here also is saying thank you so much for that from your response before. Ines says, very inspiring. The next question, Mari is asking, how can we as a small profit use data analysis to support our mission and communicate this better to our audience?
Sorry, could you repeat that question? I was reading a different question.
Oh, sorry. Yep, absolutely. How can we as a small nonprofit use data analysis to support our mission and communicate this better to our audience? I don't know if you've maybe already somewhat answered that question already, but I don't know if you wanted to elaborate at all.
Yes. So if you're a small nonprofit, let me repeat the question to make sure I understand it. You're a small nonprofit and you're trying to understand how to communicate your needs with data. is the audience your leadership team, or who's the audience for this communique?
Just let Mari maybe write into the chat here. And if not, we can always circle back to that
Great.
question.
Either way, let's say you're speaking to the leaders in your organization.
Sorry, Mari is saying our clients who receive our services.
Great, great. So this is the perfect example. Refer back to your flowchart, the flowchart that I shared. When you always need to speak to your clients in terms of, and these can be leaders in your organization or your customers or internal partners, always speak to them in terms of the metrics that matter most to them, or how you can help them help their customers. How can you help them be successful? If you're unsure of the metrics and outcomes that make your customer successful, that's when you can have an all-day offsite or a focus group or an observation study, different types of qualitative methods that can help you understand their customer needs. Start by building customer empathy, then translate that to key KPIs that you can influence with the data, and then tie them to your organization's strengths. And connecting the dots across those three areas can help you resonate with your audience better.
Great answer. Thank you. All right, so the next question is an anonymous one, and they are asking, how do you recommend dealing with imbalanced data sets? For example, a classification problem with a large number samples from one class.
Yes, so it's great that you know that your data is imbalanced. That's the first step. That's what most people miss.
Yeah.
So there are various data augmentation tools, and happy to share links with you if you can ping me on LinkedIn. There are data augmentation tools. It really depends on the type of your data set. You may be able to add noise in your data set. You may be able to just simply copy and paste, create duplicate records where you have less data, or you could remove data from where you have excess data to create a balanced data set. You could also, if it's easy, reach out to your customers and generate new data, or kick off a crowdsourcing initiative. There are various platforms. Zooniverse is what we use in AI for Earth to generate new data for those sparse scenarios.
Very cool. Very interesting. All right, we have a couple more questions. There's been lots of questions, Rian. You've been doing great with answering them all. The next one comes from Ines again. She's asking, how can we clean our database to avoid biases? It's a great question.
Yes. I would refer you to the SEEDS model of human behavior and bias. You can search for it on Google or Bing. So they're documented 150 types of biases. The quickest way, though, the first thing to do is plot your data using graphical tools. And I showed you the 4 types of broad categories of visualization that would help. And try to, on your y-axis, have age as a variable. In your second chart, have gender as a variable. And on your third chart, have age, gender, and race as a variable. And look for any correlations to these 3 variables. It's also important to look for secondary biases, for example, location. We know that people living in the Bronx, for example, may be of a specific of a specific ethnicity. So look for location-related bias as well. A great example of this is in our SIDS research. We realized that there were strong correlations to Latin American and African American populations. Our first model came out with the hypothesis that infant mortality was higher in Latin American and African American populations. But as we peel the layers of the onion, we normalizing for race, when we looked at other factors, we realized it was really smoking that was the root cause. Smoke and those particular groups of the population tended to smoke more. But when we normalized for race, we realized that smoking was the real issue. Irrespective of race, any mother who smokes is at a higher risk for SIDS than any specific type of mother. Hope that explains. So always look for correlations or biases related to age, race, gender. Also read the SEEDS model of behavior and bias. Look for self-selection bias, which was the Clinton versus the Trump example I shared, and reach out to me if you have specific questions or a specific example.
Wonderful. Thank you. So the next question comes from Josh, and he's asking, we have been collecting paper form evaluations for the past 12 years from all of our programs. What would you suggest we use to store and collate this information digitally?
Yes. Azure, I'm sure Google has, equivalent applications, and probably AWS does as well. But I'm familiar with Azure's cognitive services. There are computer vision APIs that you can use, optical character recognition. You can search for those, and you may be able to, with a quick Azure subscription, digitize, like scan those paper documents. You might need to conform you might need to train the people who are creating these forms to write more legibly, to have enough space between these characters. The API doesn't work well with checkboxes, for example. It works really well with text. So the first step is to transform paper to digital. You can use cognitive services APIs and equivalent offerings to do that. You might need to create new data or train the people to make them, machine ready, so that the AI works reliably for all your documents.
Thank you, Ria. And I think we have maybe time for one more question. And this is quite funny because I believe this might be from someone from Keela, but they're asking, it is anonymous. They're asking, my company builds a CRM for nonprofits. It is not always easy to communicate the uncertainty coming from the predictions we make about donors. Do you have any advice on how to communicate on those?
Can you share more about what the uncertainties are?
Whoever wrote that question, would you care to throw in the chat there to clarify for Ria?
For example, sometimes I've seen, uncertainty is coming from the model. Okay. So there's one example that comes to mind. It may not be your exact scenario, but in situations where I've dealt with a lot of uncertain data, it's usually when we're standing up new applications and when the frequency of data is very high. For example, we're measuring data on a daily basis, and the data fluctuates so much on a daily basis that the model is unreliable. Aggregating the data to a weekly or a monthly grain to remove outliers is what is the method I've used in the past. When you can see trend lines using graphical analysis, when you see steady trends, when you aggregate the data, that is when your data is ready for machine learning. So use graphs and use those charts to remove outliers before you run your model, and reduce the frequency of publishing.
Perfect. Well, thank you so much, Ria. It's been a pleasure to have you today.
I see one question from, I see one question from Hira. Is there a resource you could point to for small nonprofits wanting to use AI? So I have a couple of talks, this one and a previous talk, which you could use. I also recommend scikit-learn machine learning theory. It's part of my slides. It's on slide number 35. Scikit-learn machine learning theory can be a great resource for anyone who's looking to get started with machine learning. And
Wonderful.
for the
Thank you.
overall end-to-end process, feel free to refer to my slides. Thank
Yeah,
you.
and you'll be receiving those by the end of this week. All right, so, and with that, I'll just conclude the session. Again, thank you so much, Ria. That was really, really insightful. And thank you so much, everyone, for your thoughtful questions. It's been a pleasure to have you all here today. And just a reminder that our next session will start at 12 noon PST or 3 p.m. EST today. So that's in about 30 minutes or so. This Lunch and Learn session will be led by Jude Shimmer from Patron Manager, and then Sydney Wagman from the Good Partnership. If you haven't already signed up, I believe we'll be throwing the link quickly. So the link is already in the chat box. If you want to go ahead, if you haven't already registered, you can do so there. And thanks again, everyone, and see you soon. And thank you so much again, Ria. It's been a pleasure.
Thank you, Mel, Samantha, Keela team, and everyone who participated. Thanks for your questions and for making the session better. Talk to you soon.
Thank you, everyone. Have a wonderful rest of your day.